I'm pleased to introduce the Commercial and Industrial Solution MHT 25-50 Kilowatt Hybrid Inverter. This introduction will be divided into 5 parts: overview, key features, compatible batteries, system solutions, and work modes. Let's start with the first part, overview. The Solinteg 25-50 kilowatt inverter is specifically designed for commercial and industrial projects, offering a versatile power range with 5 models: 25, 30, 36, 40, and 50 kilowatts, providing customers with increased flexibility. Paired with the Solinteg Smart Meter, it enables 24-hour consumption monitoring and precise export limitation. The inverter boasts various features to help customers maximize power generation and usage efficiency. Notable functionalities include unbalanced power output, 110% continuous AC overloading, 60s 150% backup overloading, and more. These features contribute to saving electricity costs and optimizing the PV self-consumption ratio. Additionally, the inverter integrates over 10 types of protection, ensuring a stable, safe, and convenient user experience due to high-quality internal components. Further details will be explored in the subsequent slides. The inverter supports master-slave control parallel connection, accommodating up to 10 units for on-grid parallel connection and up to 4 units for off-grid parallel connection. The entire system capacity can be expanded to 500 kilowatts, and when paired with the WECO 14K3XP series battery, the battery capacity can extend to 1.71 megawatt-hour, making it suitable for commercial and industrial projects. Off-grid parallel solution is under development and will be released in the end of first quarter of 2024. In terms of naming role, M denotes the series name PowerMaster, H signifies a hybrid inverter, and T indicates 3-phase output. The numerical values such as 50K represent the rated output power, with 100 denoting the maximum charge and discharge current. The P designation is reserved for the Plus version, exclusive to the 40 kilowatt and 50 kilowatt models. Through parallel connection, the system's capacity can be extended to 500 kilowatts, making it applicable for large residential areas, villas, as well as commercial and industrial settings like malls and factories. Moving on to key features, we will delve into 6 aspects: more powerful, high efficiency, strong backup, smart energy management, user-friendly, and full security protection. Subsequent slides will provide detailed information on each of these features. The inverter supports a 150% DC oversizing, allowing the 50 kilowatt inverter to connect with 75 kilowatt PV panels. The more PV generation power can be used to support loads and charge the battery simultaneously, maximizing the utilization of green energy. The inverter supports multiple MPPTs functionality, with the basic version accommodating 4 MPPTs and the Plus version supporting 2 MPPTs. This allows for connecting PV strings with varying orientations, shading issues, or power levels to different MPPTs, optimizing the PV access and ensuring higher efficiency for each MPPT and more power generation for whole system. Additionally, the MPPT working voltage range from 200 to 850 volts, providing a broader range for the maximum power point, ensuring optimal power generation for PV strings and allowing for greater design flexibility. The inverter boasts excellent compatibility with various PV panels, accommodating different types, power levels, and input currents. We offer tailored solutions for PV strings with varying input currents of 15 amperes, 20 amperes, and 30 amperes. The inverter's PV terminals support up to 15 amperes input current, allowing direct connection of PV strings within 15 amperes. With 8 PV terminals on each inverter, a maximum of 8 PV strings within 15 amperes can be connected. In the basic version, each MPPT has 2 PV terminals, supporting a maximum MPPT input current of 30 amperes. Consequently, the basic version with 4 MPPTs can connect 4 PV strings with a current within 30 amperes. The Plus version addresses PV strings within 20 amperes current. With 2 MPPTs, each having 4 PV input terminals, 1 MPPT supports up to 68 input current, so 1 MPPT support 3 PV strings connected within 20 amperes. This allows a plus version inverter to connect a maximum of 6 PV strings within 20 amperes current. The inverter incorporates a shadow scan function, ensuring optimal power generation in shaded conditions. For a no-shadow situation, there will only be one max power point, but if shadow appears, it may be 2 or more max power point at the same time. For the normal MPPT arithmetic, it might stop at a local maximum power point to generate power. Unlike normal MPPT algorithms, the shadow scan function scans the entire voltage range to find the global power point, enhancing power generation efficiency under shading. Additionally, the inverter supports 100% unbalanced output function, enabling it to output 0 to 100% of the rated output power in each single phase, with variations possible in each phase. For example, a 30 kilowatt inverter can output 0 to 10 kilowatt in every single phase. Let's see a comparison demonstrates the advantages of the unbalanced output function. Firstly, let's see a scenario without this feature. A 50 kilowatt hybrid inverter of other brands, receiving 15 kilowatts from PV modules and 15 kilowatts from the battery, experiences a load of 5 kilowatts in L1 phase, 10 kilowatts in L2 phase, and 15 kilowatts in L3 phase. Due to the absence of unbalanced output, the inverter can only output 10 kilowatts in each single phase. Consequently, without export limitation, L1 phase exports 5 kilowatts to the grid, requiring L3 phase to draw 5 kilowatts from the grid. Typically, the cost of purchasing electricity is higher than the revenue generated from selling excess power, leading to increased electricity costs. The utilization rate of solar energy is reduced, and overall electricity consumption costs are elevated. Let's see the Solinteg inverter, particularly the 50 kilowatt hybrid model, which supports 100% unbalanced output, allowing each phase to output up to 16 kilowatts. In same conditions, the Solinteg inverter ensures load support without any power export or import, fostering energy independence, reducing electricity costs, and enhancing user enthusiasm for consumption. The inverter features a single battery port with a maximum charge and discharge current of 100 amperes, enabling the connection of higher capacity batteries without current limitations and reducing the need for the multiple battery management system modules. For enhanced power safety of backup loads, the inverter incorporates several protection measures. The UPS level switchover function ensures a seamless transition from on-grid to off-grid mode within 20 milliseconds during a power outage, ensuring uninterrupted power to the backup load. Surge protection is addressed on both the DC and AC sides with integrated Type 2 surge protection, ensuring electrical safety even in adverse weather conditions. Additionally, an emergency stop function, activated by an external switch, allows users to directly cut off the AC side output, safeguarding the system or personnel in emergencies. Recognizing the importance of alternative power sources in application scenarios, Solinteg has integrated a diesel generator function into this series. The inverter can utilize a diesel generator to supply loads when other power sources are insufficient. If the battery state of charge drops to 25%, the inverter initiates the diesel generator and puts it on standby. If the SOC drops to 20% or remains below 25% for over 10 minutes, the inverter switches the loads to be supplied by diesel generator. When the SOC recovers to 50%, the diesel generator will stop outputting. After stable operation for over 5 minutes, the inverter deactivates the diesel generator. While the diesel generator currently supports powering the backup load, the function of charging the battery by the diesel generator is under development, expected to be released in the second quarter of 2024. Furthermore, the Solinteg inverter supports smart load management for heat pumps or water heaters with SG Ready. This function intelligently determines whether surplus power is available for the heat pump based on various preset methods, optimizing green energy utilization and cost effectiveness. The inverter preset multiple control methods for smart load management function. Firstly, the inverter can, through detecting the presence of active power fed into the grid, to determine whether to supply power to heat pump. Users can customize the threshold for power detection, enabling more efficient utilization of green energy. In addition, users can also customize the SOC threshold for the battery. When the SOC reaches the set value, energy will be supplied to the heat pump for use. Furthermore, users can preset time periods based on their lifestyle habits and preferences or manually turn on or off the system through the app. Recognizing the fluctuating nature of electricity prices, with some regions experiencing negative pricing, we are actively developing a solution to address this dynamic scenario. Our team is diligently working on integrating the inverter with local electricity company API ports to access real-time pricing information. This feature is poised to empower customers to make more informed decisions about energy consumption, avoiding fines during periods of negative electricity prices and maximizing profits during peak pricing times. Anticipated for release in the second quarter of 2024, this innovation reflects our commitment to providing customers with a more cost-effective and efficient energy usage experience. The inverter is designed to seamlessly integrate with third-party energy management platforms, allowing compatibility with household appliances. We have successfully collaborated with platforms like Solar Manager, Check-a-Watt, Enjoy-Elec, and are actively pursuing partnerships with other third-party platforms to offer customers more choices and convenience based on their regional or specific needs. In terms of user-friendly features, the Solinteg 50kW hybrid inverter boasts an eye-light, a distinctive, long-shaped indicator light on the front panel. The light changes color to indicate different working statuses, providing users with a quick and convenient way to check the inverter's operational status at a glance. Below the eye light, an OLED display adds to user convenience. Beside a website monitoring platform and app, user also can use the display to check data, set parameter, or do other configuration. The inverter provide multiple channels for setting, provide more convenient to users. Furthermore, compared with traditional hybrid inverter, Solinteg 50kW inverter with a weight of only 72 kilograms, installation becomes more accessible. Just 2 persons can complete the installation, offering both convenience and cost savings. Solinteg provides a self-developed monitoring platform with a website version and 2 app versions. The Solinteg app facilitates remote control and configuration when the inverter is connected to the network. The Solinteg Set app is specifically designed for local configuration, allowing wireless connection to the inverter even without a network, a valuable feature for initial installation and maintenance. The monitoring platform is equipped for intelligent control, supporting remote control, upgrades, and management. It includes features such as failure alarms, cause analysis, visible energy tracking, and a 14-day breakpoint resuming function. Moving on, let's explore the compatible battery options. The MHT 25-50kW hybrid inverters are compatible with leading battery brands like Solinteg, Dynas, Weco, and Lithium Valley. We are actively conducting compatibility tests with other battery brands. The battery capacity range spans from 5.1 kWh to 1.71 MWh, making it suitable for diverse applications, including residential and commercial settings. For more details on compatible batteries, feel free to reach out to us or download the battery list from the Solinteg Download Center. The Solinteg MHT 25-50kW inverter offers versatile solutions suitable for various scenarios. In an on-grid system, power generated from the PV system can be utilized to supply loads, stored in batteries, or fed into the grid if there is surplus power. The flexibility extends to pure off-grid mode, allowing the inverter to independently power backup loads during power outages, ensuring customers achieve power independence. Given the changing landscape of subsidies for on-grid solar systems, many existing installations face decreased returns. In response, revamping on-grid systems into hybrid systems becomes a viable option. By incorporating a Solinteg hybrid inverter and data logger, system owners can seamlessly transform their on-grid system into energy storage system, adapting to evolving energy need. Noted that the AC coupling system needs to work with the same brand of on-grid inverter if the power export limitation is required. And the data logger is under development and will be released in the end of first quarter of 2024. Our inverter also integrates seamlessly with diesel generators, providing a reliable backup power source, as previously discussed. Furthermore, the master-slave parallel connection function, as mentioned earlier, allows for easy system expansion from 50 kilowatts to 500 kilowatts. This scalability makes the Solinteg inverter suitable for a range of residential and commercial applications, offering optimized performance and adaptability for diverse energy requirements. The Solinteg MHT 25-50 kilowatt hybrid inverter presents 5 predefined operational modes to address diverse energy requirements. Firstly, the general mode is straightforward. When solar power is ample, it supports loads, excess power charges the battery, and if any surplus power will be exported to the grid. If solar power is insufficient, the battery discharges, supplemented by grid power if needed. This mode aims to maximize the use of green energy. The peak load shifting mode is suitable for customer has power usage limitation contract with grid. If the load consumption exceed the power limitation, it may impose a fine or punishments like circuit breaker tripping. So peak load shifting mode is designed to solve the problem like this. In this mode, if the load consumption less than the power limitation from grid, the load will be supplied by grid, and solar power will charge the battery at first until it is full, then solar power can supply loads with grid. If once the load consumption exceed the power limitation, it will cause a power gap. For example, if the power limitation is 10 kilowatt, load consumption reached to 15 kilowatt, the power gap is 5 kilowatt at this time. So the solar power and battery discharging power will join in to fill the power gap, to ensure the load consumption will not exceed the power limitation. The purple area on the right side of the diagram represents the power gap, indicating an excess of power. Both the PV system and the battery will collaborate to supply energy to fill this particular power gap. The economic mode is strategically employed in regions with fluctuating electricity prices, characterized by peak and valley price periods. This mode empowers users to customize charging or discharging schedules, allowing for up to 6 distinct periods. By predefining these time slots, during valley price hours, the battery can be charged using both solar power and the grid. Additionally, loads can be efficiently supplied using either solar power or grid electricity available at valley rates. In contrast, during peak price hours, the battery can be programmed to discharge using solar power, effectively powering the load without tapping into costly peak hour electricity. Furthermore, any excess power generated during these peak periods can be sold back to the grid, capitalizing on the price difference between peak and valley electricity rates. This proactive management ensures optimal utilization of resources and financial benefits for the user. The UPS mode is designed for areas with an unreliable grid. When the grid is functioning, loads are powered by the grid while the battery is charged by both PV and grid power. The battery remains inactive as long as the grid is normal. In the event of a grid failure, PV power takes over to supply backup loads, and if needed, the battery discharges to ensure a continuous power supply in conjunction with PV power. This mode ensures consistent energy availability in regions with an unstable grid. The off-grid mode is tailored for locations without a grid connection. In this mode, power from PV is dedicated to supplying backup loads initially and charging the battery if there is surplus energy. If the PV power is insufficient, the battery seamlessly discharges, collaborating with PV to ensure uninterrupted power supply for backup loads. This mode is well suited for areas where a grid connection is unavailable, offering a self-sufficient and reliable energy solution. This is the entire content of the Solinteg MHT 25-50 kilowatt hybrid inverter. For inquiries or suggestions, please feel free to contact us. We look forward to reconnecting with you in next video.